Hello, Team Cloud Native. Welcome to another episode of ChatLoopBackOff. I am Katie Greenlee from the CNCF, and I am here with Satyam Soni, who is going to be your host for this week's live stream. Satyam is going to be diving into in-toto this week. So let's give Satyam a warm welcome. Hi, Satyam.
Hi, Katie. Thanks for the warm welcome.
Great.
So let me first introduce myself. I am Satyam Soni, and I'm a CNCF ambassador and also a Kubernetes release notes lead. And today, I have been assigned to do this chat loop backup. Thanks to Katie for that. And the episode number is 25. Before starting, I have some uh, disclaimer. I have not studied about this project in depth, so if I kind of stuck somewhere, so folks, please help me out. Uh, like, okay, I'm expecting help in return, kind of, but let's just try that. Before that, I have some news to share. Like, uh, Kubernetes version 1.31 is out. That is LA, and KubeCon uh, and its schedule is also out. Like, you can go and check out the KubeCon and schedule, and whatever's for you, you can go and bookmark for that, because there are around a lot of talks, and there's always it is always a good practice to mark your talks and go through the contents that the speaker they will be sharing. And KubeCon India ticket is live, which I am pretty excited about, and you can go and just buy the tickets and all. So let's get started with the project. The project we are having is CNCF in-toto project.
Yeah.
So
And before we get started, I just want to do one quick housekeeping notes. During the live stream, as an attendee, you are unable to talk. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there, and we'll get to as many as possible at the end. This is an official live stream of the CNCF, and as such, it is subject to the CNCF Code of Conduct. Please do not add anything to the chat or ask questions that could violate the Code of Conduct. So basically, just be respectful of your fellow participants and our presenter. And I'm going to go ahead and hide myself, and Satyam, you can go ahead and get rolling.
yeah, Katie. Yeah, okay. So the project we are having today is in-toto. So basically, in-toto is a security supply chain tool in the CNCF landscape. Let me share. Katie, is my screen sharing? Can you please confirm, is my screen getting shared? Yes. Okay. So let's go to the uh, in-toto project website, and let's get to what is this. Basically, in-toto is a framework to secure the integrity of software supply chains. So as you might be aware of what is software supply chain, I will be explaining in a bit, but I like the UI of this in-toto thing. And like there's it has mentioned something like supply chain compromises are becoming a frequent occurrence. In-toto can help you protect your supply chain. So by frequent occurrence, I was going through uh, a Wikipedia article. There was a data breach in 2020 of this US government. So this the kind of tools are pretty interesting years. And by the way, in-toto is incubating project in the CNCF landscape as of now. And okay, so let's get uh, into the complexities of what is the software supply chain and all, and what is open extensible standard. Like open, I guess open is for this is open source, and you have metadata standard. This might be having some metadata in a standard format kind of thing. So okay, and this is like extensive tooling. I'm assuming that you can use in-toto with a lot of tools, kind of. Please correct me if I'm wrong. So, meanwhile, okay, right. So let's get into the CNCF. What is CNCF in toto? The deep dive thing. Before that, like I have also, let me explain you like what is software supply chain. Like uh, it is mentioned here, a software supply chain is the series of steps performed when writing, testing, and packaging and distributing your software. So suppose like you have an idea and you are writing a code for it, you are testing it, you are packaging it, and you are distributing the software. So you never want your someone to like come someone to violate anything inside your code, or someone to come directly and commit anything inside your code that can harm either the deployment thing or the development or the backend thing. So like this is criticism. This is like I have also created a meme kind of thing to understand software supply chain basically. So this is like you have software in terms of like writing, testing, packaging, and distributing your software. So, and this is the hacker. Like in-toto is something that can protect your application from the hacker to do so, like to invade your applications and something. So you do not have to compromise on. And the interesting thing is that in-toto does not uh, protect your application like wholly. It protects your application or software at every step, for the writing of the code, for the testing, for the packaging, and for the distributing of your core software. And it is basically a typical software supply chain. Something looks like this. Like, let me draw some. Okay, you have kind of source code. You have source code, and then you like kind of build it, and then you kind of test it, and then you deploy it. Let me create another box, and then you basically deploy your code. So what in-toto does is like in-toto protects your application at every stage. Let us understand in detail like how it protects your application in detail, and we will be like updating this diagram along the as we go deep as we deep dive inside how it is doing it. So like supply chain security is crucial to the overall security of your software. Like this is obvious. Like everyone wants their software to be protected. For example, just uh, in case there is something called end-to-end encryption, and that is also over your WhatsApp. I'm giving a pretty like very basic example. Like you do not want anybody to read your WhatsApp message. So this works similar to that. Like this secures your application. Whatever the interest is of your supply chain, like the writing and testing. So this secures everything inside that, and an attacker who is able to control a step in the supply chain can alter the product of malicious intent that range from introducing backdoors in the source code to including vulnerable libraries in the final product. So as a result, it is mentioned here, supply chain breaches are impactful means for an attacker to affect multiple users at once. Like in 2020, as I mentioned earlier, this thing happened with the U.S. government, and later on, like it was also having the same. Most of the companies were also having the same issues. Although in Toto was there from 2016, I guess I have read somewhere, but anyway. So although many frameworks exist to ensure in the security last mile, and there are also some traditional approaches for the security, but the difference between like, I think in toto and the traditional security approaches is like in toto protects your application other way around. Like it does not. from testing, suppose the first step is your testing, sorry, the first step is your okay, writing, and then second step is your testing. So it tests both the steps, like writing and testing, and then it says something like, okay, this is okay to go in the production and all. So, okay, in-toto is designed to ensure the integrity of your software, basically for from initiation to end user installation, and it does by making it transparent to the user where steps were performed by whom and in what order. So, yes, this is also one specialty of in-toto. Like it mentions like who has done what kind of changes and in what order. So, like you have pretty something like Git, you can go and check out like who has changed what and in what order, and what like you can also read out some of the messages. Maybe I think that should be there. And as a result, with some guidance from the group creating the software, in toto allows the user to verify if a step in the supply chain was intended to be performed, and that if the steps was performed by the right actor. Okay, so let's read more about in the latest specification. Yes. All right. So we have pretty good things here, like in total specification, introduction, scope, okay, history and credit of in toto, the context goals. Oh wow, we have also goals for implementation, defender goals. All right. And then we have system overview, the final product, document formats, like 5 formats and all. And we also have specifying sub layouts, detailed workflows, writing code. All right, like I think we have everything covered there. So let's go inside what kind of information we can extract from this readme thing. So okay, the, the thing is that this document basically describes in total a system for securing the way in which software is developed, built, tested, and packaged, and the integrity and verifiability of all the actions performed while writing code, compiling, testing, and deploying software. It does by making it transparent to the user what steps are performed by whom and in what order. As a result, like given guidance for the group creating your software, in total allows the users to verify if a step in the supply chain was intended to be performed, and if the step performed by the right actor. And so, like I am assuming from this that we have in toto has all the steps predefined, or you have to define, you have to tell all the steps to in toto, like this manage. Okay, so let's just say like 5 steps are involved in my software supply chain, and you have to take care of all those. And this person is authorized to this thing, like x person is authorized to do y thing, and the g person is authorized to do a thing. Okay, so like and this also makes sure that nobody can tamper within the steps, nobody can perform the actions they are not having the permissions to. So, and it is like obvious that software supply chain is always very crucial when it comes to your software, when it comes to your application and anything, because nobody wants an attacker to control the steps in the supply chain. And like suppose, let's just say like you are having some payments thing and all. So you will never want, or anything, even the basic thing, you will never want anyone to invade and put some malicious things inside your code that could go wrong, and that could affect your business and everything, anything. So like let's just see the history and credit, like September 19. Oh, okay. So here it is. September 19, 2016, the version 0.1 of this document was released, and April 11, 2017, version 0.9 of this document was released. Okay, pretty good. So like in the span of like 10 months, 10 no, not probably, so 7 to 8 months, uh, we have this document has gone from zero point 0.1 to zero point 0.9. So Let's see the context basically. So as I mentioned, explained here, like you have multiple steps involved in the supply chain. That is also written here, some kind of, and goals. I think things repeating here. Over. So let's skip this part. Okay, define the goals and non-goals. Okay, non-goal is important. Like we are not trying to protect against a functionary or action in supply chain who unwittingly introduces a vulnerability while following all the steps of the supply chain as designed. Okay, so basically they are try in-toto is trying to prevent such functionaries from performing operations other than the ones intended for a supply chain. For example, like uh, if two people are in charge of running the packaging script, in-toto can verify this. In the case of verifying two toto metadata regarding this operation, so like we can assume something that there will not be two colluding or deceived developers who jointly introduce a vulnerability. That is fine. All right. Okay. So we can also read about some of the assumptions, like what are the assumptions that we need that is there. So basically, the client side tools would perform key management on the behalf of the user. That is obvious. Like, and apart from the layout key, the client is never required to retrieve and provide key verifications. We have elaborated the use of complementary frameworks. Okay, so we can read here about the complementary frameworks and all. So this is pretty good. So let's go to the context and all. Okay. Yes, terminology is something I think very important thing to understand the project in detail. So let us understand like what is software supply chain. Basically, this is the series of actions performed to create a software product. And these steps usually begins with user committing a version control system and end with the software product installation on a client system. And then you have supply chain layout, like a simple layout basically. uh, uh, you can say a sign file that dictates the series of steps that needed to be carried out in the assembly to create the final product. Okay, okay, we will be doing also the demo on it. Like we'll see like how these things are getting done. And then we have sub layout, supply chain layout that describes the steps as a part of another supply chain layout. Okay, this is pretty cool thing. It does not seems like it not only protects the one supply chain, like it can protect another supply chain associated with the one as well. And you have also the project owner thing, the authoritative figure with the project, like okay, and functionary that we have read above, like it is an individual or automated script that will perform an action within the supply chain. So basically there might be something permissions thing. For example, the actor in charge of compiling a project source code. Okay, and then we have supply chain step, a single step in the software supply chain which is performed by a functionary. Okay, and link. Yes, link is something I find important, like metadata informed gather while performing supply chain step or inspection, because the thing is that how come the first and second step know, like okay, the things, the information that I have been, or the previous, my preceding step is okay, there's no malicious thing inside that. So this is where the metadata information comes, like let's lead about let's learn about it later. Like metadata is something I think will be some kind of information, like you might have I let me recall the example. Oh yes, so in military bases, like all the military has some, when they are on operation they do not disclose their name and all, so they have some coded name. And like if you like if you get caught and you say your name, so you are saved. And but if you are not saying that particular name or anything from the group, so like you will be out of the crew and something like that. He will sort so he will sort you. kind of thing. So similar thing is happening here, maybe uh, there is some metadata and inspection and supply chain kind of thing. So made from, okay, let's just understand like something here. This step will this step will produce some metadata, and similar is the case with, okay, why is not, this is not getting grouped, okay, no worries. So this metadata will go into this build and it will verify if everything is all right here or not. If not all right, then there might be some issues, and that in toto will be able to, like, it will basically verify here what are the issues that might arise, and in toto may, let's just say, like, in toto will verify, and it will basically tell you that, okay, this is okay or not, and then let's just say, just delete this one. This metadata will verify this, and this is okay or not, and then it will go into the build thing. Maybe something kind of this happening here, there. So, and then you have materials like the element used to perform a step in the supply chain. The files generated one step and can be materials for them. And then you have product, artifact, byproducts, final product. Okay, artifacts are a material or a product as described above, basically, and byproducts are indirect results of carrying out a step, often used to verify a step that was performed correctly. A byproduct is information that will not be used as a material. Okay, so maybe STD out, standard error, and the return values are common byproducts. All right. So this is like this byproduct is used to inspect the correctness of the step. All right. So to inspect the correctness of the step, we use here something called byproduct. Okay. Okay. All right. And then the final product, the bundle containing all the files required of the software installation, and this includes link metadata, layout metadata, target files, and additional metadata. All right, and then you have client inspection step. This is basically carried out on the client's machine to verify information contained in the final product. So client inspection steps also produce a link metadata that can be used by sub layouts and other inspection steps. And then you have verification thing, the process by which data and metadata included in the product is used to ensure its correctness. Verification is performed by the client by checking the software, the supply chain layout, and links of correctness. And okay, so let's understand like what is system overview. To avoid the ambiguity, like they have preferred to any files. We prefer to any files in final product that in toto does not use to verify supply chain integrity, like the target files. Okay, so the person of in toto layout this target file is the information necessary to indicate which functionality is trusted to modify and create a such file. All right, so basically this is saying that the target file should indicate which functionaries or the which person are trusted to modify or create a file, basically the permission thing that we have discussed above. I think the things are getting repeated again here. The following are high level. The project owner. Okay, so this is how things work. The system inside the Toto. Basically, the project owner creates a layout. All right, and thus this describes the steps that every function must perform. as well as a specific inspection step that must be performed on the client's machine. And okay, so let's draw this here. Like you have a person called project owner, let's just say, right? You have something called project owner, and all right. Let's see what is inside that. And the project owner creates a layout, and this describes the steps of every function. Okay, so you have suppose like x steps involved. Let's just say like you have x steps involved. So what in-toto will do is that, sorry, the project owner, what in project owner will do that it will specify permissions to each and every functionaries, kind of. Let's just say X steps involved. So project owner will basically permissions to every step, and sorry, every function and functionaries. So basically, they are authorizing what steps can what a person can do, and in simple terms. And each functionality performs their usual tasks with the supply chain, and the client obtains the final product and verifies all the steps were performed correctly. This is done by checking all the materials and reproducts of the intended steps. Like that, the step was performed by the authorized functionary, and we also have involved parties and their roles. Everyone, like the project owner, has defined layout, and functionary performs the step, and the client performs the verification on the final product. So, project owner functionaries, you can read more about it. This and we have something called in-toto components. The in-toto components, a tool to generate and design supply chain layout. This will be used by project owner to generate a desired supply chain layout, and a tool that functionaries can use to create link, something kind of system workflow example. Okay, so this is the workflow kind of thing. uh, the script was written by, okay, someone wrote the script, and the packaging was done by someone else, and the script content the towel matches basically the packages, and the matches and that Diana wrote. And so if Bob is a malicious, or if the packaging program has an error, Carl will detect it. All right. So Diana is writing the script, Bob is packaging it, and Carl is detecting it if there is any error or something. So in order to do this, Carl will require 4 files in the final product. Like what are those 4 files? The first thing is Alice layout. Basically, the Alice, maybe the project owner somewhere. Okay, Elias is project owner who has described like something describing the requirements listed above, and then a piece of like link of metadata correspond to the Diana Jackson of writing a script, and then you have piece of a link, mm, metadata for Bob's step for packaging the script finally in the target file must be contained in the final product. So when Carl verifies his installer will perform the following checks, like something. Let's just see, understand through the diagram, like human brains understand the diagram as well. So, software supply chain definition, layout signed by allies, and you have this things called writing by Diana, and packaging. I think packaging was done by Bob. Okay, and then you have inspection by. Okay, let's see, the names has been changed anyway. Uh, by a user. Okay, all right. And the final product that you will get a bundle of link metadata, like every step. this metadata will be created, and you will get a final metadata like this is. I'm not sure what's happening here. Is something wrong? Anyway, just leave it. Leave it. Something is wrong with my mouse, I guess. Anyway, okay. So the final product must contain at least three lines, three files: the supply chain layout, the link to the metadata, and the target file. And like more complex and robust supply chain will contain more pieces of link metadata. Okay, yes. The more number of steps involved in your supply chains, the more metadata you will be having, because every step has has its own metadata. So that is it. I think target files you have, and then you have document formats. Okay, let's understand the metadata format. First and foremost thing is I think I guess the meta format is JSON file. So basically, they use JSON. Okay. So general principles. Let's just understand general principles, and then we will deep dive, and we will do a demo kind of thing to understand the project better, like how it functions and all. So the current reference implementation in Toto defines three signing methods, basically. Okay, and although Toto in Toto is not restricted to any particular key signing method like key type, cryptographic library, it is flexible with everything. So like all the keys have the format, like you have key type, you have a schema, and then you have key value. Like key type is a string denoting public key signature. Scheme, sorry, scheme. It was scheme. Scheme is a string denoting a corresponding signature scheme, and key value is dictionary containing the public portion of the key. All right. Okay. And then you have date format, like date time allows for data follows the ISO 8601 standard, I think. Okay. And hyperlink will also work here, but they have mentioned anyway. So the expected format of combined date and time string is like this format is there. All right. We will use this if the demo comes up, I guess. There will be a need of this in demo, like you have layout thing, and then you have steps. Okay, let's see. I think this is enough to understand like what project is doing, and what are the steps involved in it, kind of. So basically, uh, to understand it from the 10,000 feet view, we can understand like someone is writing the code, but they are authorized to do so, and this should be authorized to do so. And there someone is packaging, this would be authorized. If they are not, so that will be considered as something malicious. And even if they changes something uh, that is not appropriate by the in toto thing, that is not programmed in toto, that will also be considered as malicious. So we have to be careful while uh, writing the like what to say, the layout for uh, in toto. So let's deep dive into GitHub, in toto GitHub, like kind of thing. So in toto thing, let's see like what are the things. So you have the main thing here, main repo here, like in toto, and you can also go through the first and foremost thing. If you want to learn about it, you can go here in the readme thing, and you can also like from the contributor point of view, I can also uh, you can go and get us started with this. There will be something around contributing.md. You can go and check out if you are new to cncf ecosystem. Like this is common in all the projects. Like you will have contributing.md, and you can go and check out how you can contribute to this ecosystem. And the best thing is that this is written as in Python. I think I saw somewhere. Okay, let's just check like how much percentage of the code is in Python. Oh, wow. This is 100% code is in Python, so you need not to worry about if you are most of the folks do not understand like Go and all. If you're not familiar with Go or something kind of, so you can go. Python is a very easy language also as well. So you can get started with contributing to this project as well. So let's understand like the layout thing. The in-toto software supply chain basically uh, have this expiration date, all right, that we have seen, and then we have readme for optional description of the supply chain, like what the supply chain is doing and all. And then you have functional keys, public keys used to verify the link metadata signatures, and then you have signatures, software supply chains and all. So let's go in the artifact rules. Okay, only artifacts authorized by the project owner are created, no modified and deleted. Okay, this is the most important thing for the safety or for the security of your application and all. And carrying our out software supply chain steps. All right, I'm searching for something demo. Yes, in Toto demo. So you can try in Toto by running the demo application. The demo basically outlines the okay. Alice, the project owner, Bob, the functionary, and the Carl is also a functionary, and how in Toto helps to specify project layout and verify the layout has been okay. Let's go inside the demo application and see what we can try here from. So in this demo, we will use in-toto to secure software supply chain with a very simple workflow. All right. Bob is a developer for a project. Carl packages the software, and Alice oversees the project. So using, all right. So time to deal with my accelerator. Let me see. Something is wrong with my cursor, I guess. Right. Let's just delete this. Apologies for this. Like, okay. So what is being said here is that Bob is your. You have Bob, and Bob is your project owner. Okay. So basically, all the layouts will be written by Bob only, and then you have Bob is a developer, and then Carl packages the software. Carl is someone who is responsible for packaging the software. He is a functionary. Carl is a functionary, and he is responsible for packaging the software. And later on, like you have someone called. What is the name? Alice oversees the project. Okay, Carl. Okay, okay, and then you have Alice. So, like, using in Toto's name for the parties, Alice is the project owner. Okay, she creates. Sorry, and Bob and Carl are project functionaries. I'm sorry. I'm sorry. Like, Alice is the project owner. Okay, and then Bob, Carl, and then carry out the steps. All right. So let's see inside it. Okay. So let me open my terminal here. Us said that we highly recommend install in-toto and its dependencies in a view Python virtual environment. Okay, we will be doing that. So we need to first create our virtual environment Python. This Python 3 will work on my computer. All right, and we have this thing called. We have to activate this. Anyway, all right. The demo. Now we can clone this demo. We have a demo folder created, so let's inside go inside the demo folder. Let's see like what are things here. Like okay, so we have things like final product functionary, and then we have functionary Bob ls readme requirements.txt. Now we need to work on the requirements.txt. Like we need to install all the requirements that. So let's install this. Meanwhile, this is installing. Let's see uh, the structure. Like if you don't have a tree, find what and instead the tree command gives you the following output. Basically, we have readme the final product Bob, and we have this Bob and Bob.pub. I'm not sure like what is Bob.pub and Carl.pub, Alice.pub. Maybe something like they are authorized something or the metadata thing. Let's see if that comes up. Okay, note if you don't want to type copy. Okay, all right. So okay, let's go here. Python create update the version in total required package card. So first we need to define the software chain supply chain layout allies. All right, we are going to doing the we are going to do the faster step. This one. Okay. Uh, let's like pen. Okay. We are going to this step now. So first we will need to define the software supply chain layout. To simplify the process, like they have, we need to create this cd owner.allies. Right. Owner.allies, we have this, and we have Python 3 create underscore layout. So we have layout, the layout thing, and the script will create a layout. Add Bob's and Carl's public keys here. Okay, that pub I think is public keys fetched from the directories. Sign in with the allies private key and dump it in the root.layout. Root. Okay, this script will create a layout and kind of and the functionalities authorized to perform. So how to do this? Do this like hit Bob's and Carl public keys. Sign in with the allies private key and dump it into the root dot layout. So how can we find out the public key? I think the tree command will work. Let's see. We need to vi stop. Nothing is there. So let's just say cd. Let's go inside the demo and we will see if that is there or not. On realize now clone source code Bob. So we need to go inside the Bob's. Okay, and in-toto run step. We'll take the yeah. All right. We need to clone this project there. Here's what happens behind the zone. This basically in-toto wraps get command and hashes the contents from. All right. It stores everything in Bob's key ID. Okay, so we can check like Bob's key ID if Bob. Okay. No, we do not have anything like that. So update the version number. Before call package the source code, Bob will create a version number hard coded into foo.py. It does this using the in-toto record. So let's update like Bob is the one who is responsible. We are doing things on on behalf of Bob now. So let's just okay, sorry. Think that this will work. Okay. So we just updated the version now on behalf of Bob. Then Bob used an editor of his choice to update the version. Example. Okay. Let's just copy and paste this command. Alright. And finally he records the state of the files after the modification produces a link metadata called update version bob.link. So we need to update this. Bob has done his work. So we need to this is the final step for Bob's work. Okay. And then Bob has done his work and can send over the sources to Carl. Now, who will create the package for the user? So let's just go inside the Carl repo. So, all right, and what Carl will we are now inside. Okay, this just copied the work from Bob into the Carl directory, and then let's go to the Carl directory. Just copy this. Right. So this will create another step link metadata and all, and package the Carl's key ID, time to release. So verify. Let's just verify our final product. So I'll bring my terminal here, and we will go to the project main directory demo and just copy this thing. Copy the all right. Now we'll go inside the final product and we'll again copy the public key here in the box and CP owner Elise pub. I think we need to go inside the first final product. Fetch Elise public key from a trusted source to verify the layout. Note the functionally public keys are fetched from the layout. So we need to copy this. Now this might work. Yes. Okay, and in-toto verify root layout kind of thing. So let's do this as well. Okay, this command will basically the layout has not expired and was signed by a live private key and that according to the definitions in the layout. So its step was performed and signed and authorized. So from it you will see the meaningful output passing and return. Okay, let's just do the so dot zero. If it outputs zero, then return a value of zero that indicates the verification worked out well. So fingers crossed. Let's just see like if that worked. Okay, that worked. Like we have zero and tampering with the software. Now, okay, let's do one thing now. That was everything pretty fine. Like everyone was doing their job, and let's just say like this has done, this has done. So now let's just tamper with the data. Let's just tamper now, and we will see what happens. Like I think when tampering, we will see the output one. So let's just tamper with the data. Now we need to go inside the functionary cat. So I think control. We are here. Now Carl will tamper. Carl is not a good guy. He will tamper the data. Okay. All right. And let's just run this. See and see what happens here. Yes, successfully like kind of tempers the data and ships out as the final product to the client. Now let's see like what happens here. CD and Iona. All right. Now let's just verify the final product. Just go into the CD and if check like in-toto is working fine or not. CD final product. That is it. And in-toto verify layout, root layout kind of thing. Okay, okay, okay. I think I copied a lot of things. We need to get alice.pub. Okay, so full trust for expected materials of item package. So in total, right, available materials used for Q demo project 4.py and available project Q after match project with products updates version. Alright. So let's just check like if that is updated or not. Echo kind of for the command. For alert. So we get one like Cal was successful in tampering our software supply chain, and in-toto is more smarter, and in-toto is successful in detecting this. So basically, this is how in-toto works. Uh, so in summary, like you have Honor, who has defined all the layouts and who has defined all the permissions to Bob, Carl. Let's just say he has 10 functionalities. He has defined 10 different functions and 10 and that is very specific. So if someone does anything that is out of scope of that layout. In-toto, what in-toto does is it basically marks it as a malicious thing, or and basically when it will go to the next step, in-toto will automatically mark it kind of and will not proceed the things further. So this is how in-toto works, and you can also lay out like tampering with the software supply chain. So now let's try to tamper with the software supply chain. All right. So this was tampering with the package card. Now let's try to tamper with the software supply chain. Now we come to the CD Carl's directory. Carl is not a good guy. I'm once again saying it because Carl is doing a lot of things that is not okay. So okay, let's. Carl thought that this is the genuine code he got from Bob, and unwittingly packages the tampered version of the of foo.py. So let's do the Carl's job. I am Carl now. All right, and let's go to the cd dot dot. Right, and then you have cd alias kind of thing. Okay. Let's go to the final product to detect the malicious things, and kind of things. Demo. All right. I think, and once we do the echo command, it should output again one because he has tampered with the supply chain now. Sorry. What a question like this. So again, we get one. But basically, the in toto is again successful in detecting the malicious things. Anyone like Bob, this time intentionally Bob has not done something. So anyway, this proves like whatever hard coded thing in toto, whatever you coded inside your layouts thing, in toto will understand only those things. So be mindful of uh, defining your layout and all, and so that is how in toto works. Pretty good thing. So let's just wrap it up now. Let me delete all the things from here. Okay. Right. So tired of copy pasting commands, we can also run something like we could have done that to save our time, but I wanted to do it manually to learn. Basically, this chat loop backup is all about running. So define supply chain layout alias, press any key to continue. So let's just do this thing as well. So okay. Created a demo in total layout as root layout. Now clone source code, press any key to continue. Now this will basically this has basically cloned the source code and update version number. Okay, Bob will update any of the version number. Okay, this prints like something print hello world in total record stop kind of, and it is also extracting link from metadata. So yes, this is something that has more information kind of thing, generating the link between DSSC. So this is also anyone has got any idea like how to see the metadata contents. Let's see later on if I can find anything kind of that. Press any call now in toto, like basically sorting the link, create a final product, verify the product. Okay, no one is just the card, the thing that we have done in the first step. Like The Carl has done what he was intended to do, and we did not get any issue. Like now, tampering with the supply chain thing. So it was something else demo project. Now press. We need to let's just see, like if Carl is intentionally doing something malicious kind of thing. Okay, so same thing. It's getting repeated, but anyway, this is fun. So yes, in total is kind of. So if you are tired of doing all the things uh, by a command by copy and pasting the command, so you can try this. But I will still suggest you to go and try, because that gives you a lot whole idea. But I had a question like how to see this metadata kind of thing. Let's.
Unfortunately, we're at time. So if you want to take another few minutes just to wrap it up. Um,
Yes, Katie, like we can do. Yeah.
Great.
So I was just wrapping up. I'm done with the demo and all. So we can do another session on in toto, like kind of where we can also explain like how we can contribute to in toto and things. So I'll explaining in the second part like how to contribute and all the intricacies of in toto, like how the metadata and things work.
Great.
Right. So thanks everyone for joining, and hope you got to learn something.
Yeah, thank you, Satyam for hosting this week. We really appreciated it, and we look forward to having you back on ChatLoopBackOff for a future live stream.